In this video, we're going to cover some practice problems to get ready for the test coming up on sections 2.6, 2.7, and 2.8. So let's try a few of these out. For the first batch of problems, 1 to 3, we want to just find the domain of each function. So in the first one, we have a radical. Of course, to find the domain, we want what is under the radical to always be positive, or greater than or equal to 0. And I will subtract 6 from each side. X must be greater than or equal to negative 6. That's good for the domain. If you want to write it as, you could also write it as bracket negative 6 comma infinity. Or if you like set builder, you could write the set of all x such that x is greater than or equal to negative 6 would also work. Okay, second one. We got a fraction. Of course, our worry here is division by 0. So we want to set our denominator not equal to 0. We want to set it not equal to 0. And then subtract 3 from each side. X cannot equal negative 3. This with interval notation, you'd have to write negative infinity to negative 3 parenthesis unioned with the other set of negative 3 to infinity. Notice we didn't use brackets here, and that means that this number on the end is not part of the solution. So here, the parenthesis on negative 3 and also this parenthesis on negative 3 shows that's the only value that has been excluded from the domain. Easier to write this or the set builder notation, the set of all x, such that x does not equal negative 3. And of course, I saved the tricky one for last. We have two terms, radical x minus 1 and plus radical x plus 5. Well, let's think about separately. The domain of the first radical will be all the x values greater than or equal to 1. And the second radical would be the x's greater than or equal to negative 5. We can only pick numbers that satisfy both of these domain restrictions. And this might be easy to think about graphically. If I got a number line here, and I'm going to do, well, let's see. We'll go from negative 5. I guess I'll put 0 here. 1 would be about here, and 2. So if I look at the first one, all the x values greater than or equal to 1, I would be bracket at 1, and then go into the numbers greater than. And then for the second radical, greater than or equal to negative 5. So I would be here at negative 5 and headed off to greater than. The domain of the combined function, both of those together, will be the overlap of these other two. So here, I'm only hitting the one for the radical of x plus 5. I don't start hitting both until I pick up right here at 1. And then from there on, those two domains will overlap. So this will be the domain of the combined function, radical x minus 1 plus radical x plus 5. Our domain here would be 1 to infinity. Or interval or set builder notation, the set of all x such that x is greater than or equal to 1. And there's our domains. Number 4. This is a four-parter. We're going to find two functions here. F of x is 3x minus 1. G of x is x minus 5. We're going to find their sum, their difference, their product, and their quotient. So for part A, we're just adding. If we're adding them, here's our first function plus our second function. Since we're adding, the parentheses are basically meaningless. Collect your like terms. 3x and x is 4x. Minus 1 and minus 5 takes us to minus 6. So there is f plus g of x. F minus g, you got to be careful. The f function goes first, 3x minus 1, and then we're going to subtract the g function as a quantity. It must be in parentheses. The first set of parentheses don't really matter much, but to drop the second set, we have to distribute the negative. So that'll become a minus x and a plus 5. So for f minus g of x, we collect our like terms here. 3x minus x is 2x, and a 5 minus 1 is plus 4. 2x plus 4. Multiply. We want to multiply the two functions. 3x minus 1 and an x minus 5. So we got to FOIL this out. First times first, 3x squared. our outers will be minus 15x and a minus 1x with the inners, so that adds up to a minus 16x. And then a minus 1 and a minus 5 multiply to a positive 5. And there's our product, f times g of x. Letter D, we want the quotient, f divided by g. So f goes on top, g goes on the bottom. They did not ask for the domain, but let's think here. We would just want this denominator, x minus 5, to not ever equal 0. So the domain here would be x cannot equal positive 5. On to number 5. This is the function composition. For part A, we're going to compose f of g of x. F of g of x. So the outer function is f. G is going to go into the f function. So I'm going to copy the f function without the x in it. The f function was the square root of something. The something that we are now square rooting is the other function, x squared minus 3. And it does say to find the domain for each. So if I look at this one, I have a radical. Well, first, remember, we always got to look at our inner function. Our inner function's domain for g of x here is all real numbers. So we don't have to worry about the inner function. Here, our final result, we have a radical. And of course, we want what is under the radical to always be greater than or equal to 0. And if I add 3 to both sides, x squared must be greater than or equal to a positive 3. And then when I square root, it's going to be x must be greater than or equal to the square root of 3. Would that be plus or minus? Yeah, so we would have our plus and minus here. So the positive root is going to stay on this side. X must be greater than or equal to the positive radical 3. And on the other side, we'll have it jump over here, our negative radical 3. Negative radical 3 must be greater than x, or x must be greater than 3. So if here's 0, and here's radical 3, we have to be greater than or equal to that. And over here would be the negative radical 3. We have to be less than that, or this negative radical 3 has to be greater than x. So here we have excluded numbers between 3 and negative 3. And let's see, does it make sense? A little bit bigger than radical 3 would be a positive 2, and a little less than a negative radical 3 would be a negative 2. Can I plug in a positive 2 or a negative 2 without bad things happening? Well, let's see. If I plug in the positive 2, I would get 2 squared, which is 4 minus 3, and that's fine. It's a positive 1 under the radical. If I plug in a negative 2 and square it, I'll get a positive 4 and minus 3. That is also greater than 0. So here's our domain. All the numbers outside of 3 to negative, or radical 3 to negative radical 3. That was a tricky one. So that was part A. We found f of g of x. Let's look in the other direction. Part B is g of f of x. So the outer function is g. I'm going to copy my g function, which was x squared minus 3, leaving an open spot where the x was. And into that open spot goes the f function, root x. So let's see here. If I square this radical, it just becomes x minus 3. So here's my composed function, and if I look at just this, it looks like my domain is all real numbers. But remember, we also have to think about our inner function. The inner function is hidden inside this composed function. When we squared the square root, we lost sight of the radical. But remember, we have to obey the inner function's domain. And the domain of just this f function, our square root of x, x must be greater than or equal to 0. So this all real numbers is not the final domain. We have to obey that inner function that says our x values can only be positive, greater than or equal to 0. It sure looks like we can plug a negative number in for this x without dividing by 0 or having a negative under a radical, but our inner function is hidden in there. We also have to obey its domain. The last one is g compose g. The g function by itself has a domain of all real numbers. When we compose it with itself, again, the domain is all real numbers. This composed one, g compose g of x, will also have a domain of all real numbers. So the g function was x squared minus 3, but I'm taking out the x and I'm replacing it again with the g function, x squared minus 3. All right, if we FOIL that out, our leading term will be x to the 4th, and then we'll have a minus 6x squared, and then a plus 3 squared is 9, and then we have this minus 3 at the end. So when we collect up all our like terms, which are just the constants at the end, x to the 4th minus 6x squared plus 6. Again, the domain will be all real numbers. The final product's domain is all real numbers. The inner function g of x also had a domain of all real numbers. All right, number 6, time for some inverses. There is supposed to be an inverse right there. So given f of x is equal to 4x minus 3, first find its inverse and then verify that the inverse is correct. All right, 4 steps. Step 1, take out f of x, replace it with y. Step 2, switch the variables. X and y change places. Now we're going to solve for y. Add 3 to both sides, so this will be x plus 3, and then divide by 4. So we get x plus 3 over 4 is equal to y, and then we take out this y and replace it with f inverse of x equals x plus 3 over 4. And it did say to verify. We have to verify that these are indeed inverses. So here is f of x, and the inverse we just found. Well, let's find f of f inverse of x. So f, I'll copy the f function without the variable x, and I will replace the variable x with the inverse we just found. So here we can see we are multiplying and dividing by 4. Those will cancel. So now we have x plus 3 minus 3. The plus 3 minus 3 cancel, and we're left with x. That worked that way. Let's try the other way, f inverse of f of x. So I'm going to copy the inverse function, leaving a gap where the x was. So we had something plus 3 over 4. And now in for that variable goes the f function, 4x minus 3. So let's see, the plus 3 minus 3 cancel. So we have 4x over 4, and the 4's cancel. So we are left with x, and we have verified our inverse is correct. Number 7, find the inverse of this one. All right, step 1, replace f of x with y. I want to clear fractions. I'm going to multiply everything through by x. So I get x times y equals 2 plus 5x. Let's get, yeah, we'll get all our x's. Ooh, I forgot to switch my variables, didn't I? Ooh, naughty me. Back up. Step 1 was to replace the f of x with y. Step 2, swap the variables. X equals 2 over y plus 5. Now we multiply through by y. So I'll have xy equals 2 plus 5y. Now we want to get y alone. So we're going to get that 5y term on the left by subtraction. So I'm going to subtract 5y from each side. Xy minus 5y equals 2. And here I can factor out a y. Each term has a y value. Bring it outside the parentheses. So here we are left with x minus 5. And that's equal to 2. And to get y alone, we're going to divide both sides by this quantity. Y equals 2 divided by quantity x minus 5. Replace the y with our f inverse of x. And there's our inverse. 2 over the quantity x minus 5. Okay, now for some easier stuff, distance formula. We're going to have our big radical, and under that radical are some squared quantities that are added together. In the first one, I'm going to subtract my x's. Well, I'm going to go the other direction. Why not? I guess it won't matter. 3 minus negative 2. And then for the y values, negative 9 minus 3. So let's see here. Add the opposite. That becomes a 5, and we square it 25. Here we add the opposite and get a negative 12, and square that and get 144. And if we add those numbers, we get 169, which has a perfect square root of 13. So it says if necessary, round to 2 decimal places. It wasn't necessary. We didn't have to round it off. It is a nice perfect whole number, 13. All right, midpoint. Here we have a endpoints of a line segment. We want the midpoint. Again, I like to do it this way. I add my coordinates and divide by 2. So if I line them up and I add them together, I'm going to get a -10 and a +10. And if I cut those values in half, I'll have my midpoint, -5, 5. Easy peasy. Number 10, here is the center and the radius of a circle. Write its standard form. All right, well, I'm going to have x minus my x coordinate, -2, quantity squared, plus y minus my y value of 4, and that quantity is squared, and that is equal to the radius squared. So here we will add the opposite. That becomes x plus 2, quantity squared, plus y minus 4, quantity squared, equals 36. There's our equation, standard form of a circle. All right, last one. Here's an equation of a circle. The center, the radius, we're going to graph it and then use the graph to identify the domain and then the range. Okay, when I look at this equation, I see a +2, so I know my center is going to have the opposite, a -2x coordinate. Here for the y value, I see a -3. I'm going to change that to a +3. So there's my center, -2, 3. We want to find the radius. This is the radius squared. So the radius is going to be the square root of that number, or 3, radius 3. For this part, we're going to graph it. -2, 3 is our center. From there, we will go 3 units in any direction, up, down, left, or right. And there's our circle. For C, we want the domain. Domain lines up with the x-axis. So if I look down here, my x-axis, the circle starts at -5 and goes to +1. So there's my domain. Bracket -5, +1, bracket. Or you could do the set of all x such that -5 is less than or equal to x, which is less than or equal to 1. And the range is the y-axis. So here the top of the circle lines up with 6 on the y-axis, and the bottom of the circle lines up with 0. So it looks like we're going from 0 to 6 in brackets, or in set builder, the set of all y, such that 0 is less than or equal to y is less than or equal to 6. And there we go. I believe that's the last question. I hope this helps you on the test.